Welcome to the deep dive. If you're a leader, an executive, or just someone really trying to figure out what's next, you're probably past the point of asking, does AI work?
Oh, absolutely. The pilots have been run.
The demos looked great. We know the technology works.
Exactly. So for leaders right now, the real question isn't if you should deploy, it's how. How do you scale that successful pilot across the entire enterprise reliably, safely, and, predictably?
We've graduated from the lab.
We have. The challenge is now structural.
Okay.
It's about designing the organization itself around this new digital capital.
And that structural challenge, that's our whole mission today. We are going to be unpacking the blueprint you need, drawing on the new work, scaling digital capital. And if the first wave of AI talk was, let's say, the conceptual handshake, this is really different. The author, Chris Tansey, calls it the hard hat.
I love that. It's the architectural plan. It's for building a resilient AI augmented organization from the ground up. We're moving beyond just speed and into, structure.
So this is about making sure AI isn't just a fun, siloed tool.
It has to become core, load-bearing infrastructure in your business. And that architectural work is what separates the temporary adopter from the enduring transformer.
Okay, so our goal is to distill the non-negotiable principles for leaders to scale effectively. And we're going to focus on where traditional business thinking, frankly, just breaks down.
Completely breaks down.
To set the stage, we're pulling 4 provocative hooks straight from the source material. These will sort of guide our deep dive.
These are the structural truths.
Yeah.
And they often feel a bit counterintuitive, but they define successful scaling.
Okay, first one. Why your org chart is lying to you.
Second, why 95% of AI projects fail, but the metric is wrong.
I'm very curious about that one. Third, the danger of garbage in, confident garbage out.
And finally, and this one is critical, the reality that shadow AI hides best in fear. It surfaces fastest in trust.
All right, let's start with the foundation. We've said the era of experimentation is over, but what's the actual, the hard evidence that AI has truly graduated from an R&D project to enterprise infrastructure?
The spending signal is, I think, the clearest evidence you can find. Enterprise AI spending didn't just inch up, it exploded.
Okay.
It went from $2.3 billion to $13.8 billion in a single year.
Wow, that's a 6-fold increase.
A 6-fold increase. I mean, when you see that kind of capital commitment, that is not R&D money anymore. That is infrastructure money. It signals a permanent organizational change is underway.
And the capability leap has to follow the money, right? It's not just about spending more, it's about what the tech can now do for you.
Absolutely. The capability leap is the real story. It's the shift from a simple chatbot to a sophisticated agent, or really a coworker.
What's the difference?
Well, a chatbot automates a conversation. An agent automates a contribution. It takes ownership of entire tasks. The best example of this is IBM.
What did they do?
They took this so seriously, they closed their internal IT phone lines. Completely. Because their AI agents now resolve 82% of all support requests with zero human intervention.
So they didn't just add a tool, they replaced an entire operational system.
That's it, exactly. It's a fundamental structural replacement.
That's a staggering transformation. But, when we see change that big, we expect a financial return almost immediately.
Of course.
And this brings us back to that second hook, the measurement problem. If this is now load-bearing infrastructure, why are we seeing studies that say 95% of generative AI projects fail to deliver a measurable ROI in 6 months?
Because the interpretation of that number is flawed. The 95% number is real, but it doesn't mean the tech isn't working. It means traditional ROI. The simple question, did you make more money than you spent, is the wrong metric.
That sounds like heresy to a CFO. Why is ROI the wrong yardstick here?
Because ROI measures the direct, short-term hit to the income statement. You wouldn't judge the ROI of, say, rebuilding your company's data centers after 6 months of revenue.
That's a fair point.
These are transformation assets. It's about long-term capacity and strategic leverage. You're measuring too early and you're measuring the wrong thing.
So we have to shift the focus. You introduced this concept of ROE, return on efficiency. What questions does that framework ask that ROI just ignores?
ROE asks a much more strategic question. It asks, what can you now do that you couldn't do before? It measures the gain in capacity, the improvement in quality, the increase in speed. Those are the drivers that enable massive revenue shifts, years down the line.
Can you give us an example of that ROE value in practice? Where has an organization gained capacity they couldn't just go out and buy?
Look at Siemens. They used AI to identify manufacturing defects with 100% quality assurance. But they do it while performing 30% fewer X-ray tests.
Okay, so that's a direct efficiency gain.
It's a permanent gain.
Right.
It saved them $500,000 in capital costs, not by cutting people, but by slashing waste and inspection time.
I see.
Or think about Colgate-Palmolive. They deployed AI for predictive maintenance. It prevented a major motor failure that would have caused 192 hours of downtime.
And that downtime would have cost.
It would have meant losing 2.8 million tubs of product. So that value, that guaranteed uptime and protected capacity, that is pure ROE. It's the cost of failure avoided.
Which is often much greater than the cost of implementation.
Much greater.
That reframing is essential. You're not just tracking costs cut, you're tracking capacity created. And that capacity is generated by these new synthetic workers, which brings us to our next section.
Precisely.
Let's move to the synthetic workers themselves. We'll start with the synthetic developer. Studies show developers using coding agents are completing tasks 55% faster, which sounds incredible.
It is.
But the book calls this agent a zealous apprentice. Why is that speed potentially dangerous?
The speed is the lure. The danger is that the synthetic developer is hyper-literal. It will build exactly what you ask for, even if your request is architecturally unsound, insecure, or just irrelevant to the business problem.
So the human job is no longer holding the hammer.
You're checking the plumb line. That's the perfect metaphor. The specification is the work now.
What do you mean by that?
Well, for decades, a spec was just guidance, a starting point. Now it has to be the complete ironclad contract between your intent and the agent's execution. You define everything: the intent, the constraints, the exact tests for success, the definition of done, all of it.
So if the code comes out crooked, you can't blame the agent.
You can't. The blueprint, your specification was wrong.
But for an established company, isn't requiring a complete contract for every piece of code just adding bureaucracy? Won't that slow down agile teams?
It feels like it, but it's not bureaucracy. It's shifting quality assurance upstream. A human coder applies intuition to a vague request. The agent doesn't have that.
It just fills in the blanks?
It fills in the blanks with his training data, not your business logic.
Yeah.
And you probably won't like the answers. So the human effort shifts from execution to what I'd call forensic specification. You save time on coding, but you have to invest that time in precision up front.
That flips the entire development workflow on its head.
Okay, let's shift to the synthetic researcher. It can process impossible volumes of documents, but you say it introduces a confidence trap.
Yes, and this brings us right back to our third hook. Garbage in, confident garbage out.
Right.
Hallucination isn't really a bug, it's a structural feature of the technology. These models are designed to produce plausible sentences based on statistical patterns. They don't check a database of truth.
They're just generating what sounds most likely.
Exactly, even if it's based on bad data or, non-existent facts.
And this risk of plausible untruth gets a lot bigger in specialized fields. It's one thing to make up a historical anecdote, but what happens when it makes up case law or medical citations?
That's where the danger becomes acute. The hallucination rates are much higher and the consequences are far greater. We see rates around 6.4% in professional legal research.
That's not insignificant. Not at all. In medical research citations from tools like GPT-4, the error rate can approach 30%. And the insidious part is that the output looks perfect. The citation is formatted correctly, the language is professional, but the source just doesn't exist. It has high confidence, but zero accuracy.
So if an agent gives you a brief based on 100 documents, you can't just trust it blindly. Your job shifts from searching to verifying.
Absolutely. The human's role is now auditor. You can't possibly check all 100 source documents, so you have to install a system, a verification protocol, to focus human judgment where it matters most. This is where concepts like the 5-document rule come from.
Okay, explain that. How would a leader practically apply the 5-document rule?
It's about selective, high-stakes auditing. When the AI processes a huge volume of information, you have to focus your expert human attention on the 5 claims that carry the highest consequence.
The linchpins of the argument.
The decision-driving numbers, the attributed quotes, any counterintuitive conclusion that might change your strategy. You don't verify the mundane stuff. You verify the claims that would cause massive damage if they were wrong. It's just professional discipline.
We've established the need for structured inputs and auditable outputs. Now let's zoom out from the individual worker to the system they operate in, starting with the data substrate.
The floor your synthetic workers stand on. This links directly back to that GI Go hook. The agents are general. It's your data that makes them specific and useful.
So if your data is dirty or biased,
Then those flaws get amplified into confident, but ultimately flawed outputs. This means you need a dedicated focus on data quality architecture. It's not glamorous work, but it's essential.
what are the non-negotiables there? It's more than just clean your data.
Oh, much more. You have to focus on what the book calls the 7 dimensions. But the key areas to start are quantity. Is there enough context? Accuracy. Is it correct? Timeliness. Is it recent? And curation. Is it labeled and structured properly? Without that deep work, the performance ceiling on your expensive agents stays dangerously low.
Okay, that gives us the floor. Let's talk about the organizational walls. This is where that first hook comes in. Your org chart is lying to you. That's a bold claim. Why is our current org structure obsolete?
Because AI agents have crossed what we call the coworker threshold. They're not just external tools you use anymore. They are integrated, stage 4 partners performing real load-bearing work inside your systems.
Like the IBM example.
Exactly. The moment an AI agent performs, say, 40% of your support team's tasks, that agent needs a place on a synthetic org chart. And the humans who remain have to take on completely new roles.
So the traditional structure of deep vertical silos just doesn't work anymore.
It can't. The work is now distributed between human and synthetic agents. This demands 2 near-human archetypes. First, the M-shaped supervisor, who manages across multiple domains and orchestrates the agent workflows.
And second,
The T-shaped expert, the person with deep expertise who is reserved for handling the novel, complex, or ethical edge cases that the agents can't touch.
and how do these new roles fit together?
You scale by creating small cross-functional units. The book calls it the pod model concept. It's where your M-shaped managers, your T-shaped experts, and the agents are all embedded together with a clear mission. Your org chart is lying to you because the boxes suggest rigid accountability, but the real work is happening dynamically inside these integrated pods.
So leaders need to stop managing job titles and start architecting pods.
That is the job now.
Okay, finally, let's talk about the operating system for all this. Governance? Rapid scaling sounds like the perfect environment for shadow AI to thrive.
It is, which brings us to that last hook. Shadow AI hides best in fear. It surfaces fastest in trust.
What's the specific risk of shadow AI now that it's moved beyond just, file sharing to influencing strategy?
The risk is profound. Shadow AI, the unsanctioned use of powerful tools, often bought on personal credit cards, is now generating sensitive documents, drafting production code, influencing critical decisions, all with zero oversight, no audit trail, and no quality control.
So if a leader just bans external AI tools thinking they're mitigating risk, they're actually making it worse.
They're making it so much worse. Prohibition is the worst possible response. Because the utility is so high, employees will use them anyway. They'll just hide it. Fear drives it underground.
And when it's underground, you can't monitor for things like prompt injection or data leakage.
Can't see any of it. So the governance response has to be about enabling safe use, not restriction. Trust means creating sanctioned pathways, a clear policy, a central agent registry, AI-specific security controls.
You give them a safe, approved alternative.
Exactly. And the risk here isn't theoretical. Organizations with AI-specific security controls reduce their data breach costs by an average of $2.1 million, compared to those just relying on old security measures. Governance is not a cost center. It's essential risk reduction architecture.
This has been a critical architectural deep dive for any leader who has passed the pilot stage. The core takeaway feels very clear. The age of experimentation is over.
It is.
The competitive edge is no longer just in adopting tools faster, it's in designing the system, the architecture around them better and more safely.
That structural work is the ultimate differentiator now. You have to audit your digital balance sheet, adopt the ROE framework, build that synthetic org chart, implement verification protocols. Chris Tansey provides this as pragmatic engineering, not academic theory.
It's the checklist and the templates.
It's the patterns you need to actually construct the integrated system.
It sounds like you're going from managing a contractor to architecting a vast, interconnected construction crew.
And that level of discipline is absolutely non-negotiable if you want to scale. We've only really scratched the surface of these frameworks today. The full playbook has the 7-step governance plan, the complete architect's checklist, everything you need to move digital capital from potential to reality.
The blueprint is complete. The question is whether you'll design the system or let the system design itself around you.
Embrace the necessary and, let's be honest, non-glamorous structural work required to scale your digital capital. That's how you secure your competitive advantage for the next decade.